Howdy, this is Daniel Vedova, and this is my 15112 term project. And for my term project, I took a existing robot in my lab and upgraded it with a Kinect and a Wi-Fi router so that it has wireless capabilities. Um, with this robot, you can see in this picture, it's a hexapod. It's highly dynamic and very versatile. It's a very cool looking robot. Here's a picture of what I designed on the inside. We got a Wi-Fi router, a power distribution board, a battery pack is also configurable, but it's kind of cumbersome to test with a battery pack, so in all these videos you see a tether cable locked in. Here's an actual picture of what the guts look on the inside. There's an Ethernet switch on the bottom, a Wi-Fi router in the back, and the power board. Here's a video of some of the active control I do with the Kinect on the snake monster. Right now you can see me pointing to the left, and the snake monster is moving to the left. Continues moving to the left, keeps moving to the left, and then right here it pauses because it lost track of me. Now it's moving to the right, moving to the right. The snake monster is constantly tracking me and checking my distance, what kind of gestures I'm making with my hands. Now I just made a gesture to move forward. And then we break into another video right here. So the snake monster sees me. I tell it to move again. I'm actively controlling it. I'm telling it to move to the left. What's really cool about this robot is it has a lot of military applications, and that's what my research has been about, is how to increase human-robot interaction for military type robots. So for this robot, it picks up on some classic hand and arm signals that the Marine Corps uses. Like, for example, you'll see a lot, I raise my right hand over my head, and that means stop. It's like a silent command to tell someone to stop, and the robot responds to that. Yeah, now I'm telling it to move backwards. So one of the interesting things about this robot is that it can also passively follow. Before I was actively controlling it, now I'm passively controlling it. I'm not exactly paying attention to it too much. It's tracking me and it's trying to maintain a set distance. So right now it realizes that the threshold got hit and it's trying to catch up. So every time it pauses, it's checking whether or not that threshold's been hit. It realizes the threshold's been hit and it moves forward. If I were to get too close to the robot, it would back up. And it's going to keep following me like that for as long as that cord will go. Right here, it's actually tracking multiple people. This is what's interesting for the military. Robots need to be able to pay attention to multiple people at a time. So right now, when the robot's looking at me, I'm the leader in the middle, but it's also paying attention to two people on the side. So right here, you can see that the robot pays attention to all three people, but it only listens. The two followers on either side can tell the robot to stop, but they can't tell the robot to move. Right here. This next clip we're about to see is really cool. So I took one of the recursive backtracking algorithms that we learned in class and I applied it to real life. So right now it's trying to dodge me. I am an obstacle and it detected me and now it's trying to move around me. So it just shifted to the right. It saw that the path is clear and now it's going to move forward to the finish line. The robot's goal to solve the maze, you could say, is to move forward past me. So it shifted to the right. Notice that its path was clear, and then it continues moving forward, and then it stops right there. And then the last thing I did with this robot was I made it respond to speech. So it has voice recognition software on it. It's using Google's voice recognition API, and it's responding to my voice. Right here, it just heard that I said contact right, and now it spun to the right and sat down and took cover, you can say. Now it's moving forward. I told it to rush, and that was to attack, and that's about it for my robot. Lastly, I would like to thank all the guys at Heavy Robotics, a CMU-based robotics startup that helped provide me with all the hardware to build the upgrades for my robot, other than the Kinect. Those red modules you saw were designed by mechanical engineers at Heavy. Thank you specifically to Julian Whitman, David Rawlinson, and Simon Kalunch who wrote the actual locomotion code that controls the joint angles and the low-level controllers on the modules to actually make the robot move. Um, okay. And that's my turn project. Thank you so much.